Welcome to our lecture on the mechanics of interest rate swaps. Today we are going to explore how financial institutions manage risk by trading their interest rate obligations. This is a fundamental concept in mathematical finance. By the end of this session, you will understand exactly how these powerful contracts work behind the scenes to stabilize unpredictable markets. To understand swaps, imagine two friends, Alice and Bob. Alice has a fixed $10 daily meal plan, while Bob pays a flexible daily market price. If Alice wants flexibility and Bob wants predictability, they can privately agree to pay each other's costs. They have just executed a swap to trade their payment structures without changing their original contracts. In the financial world, companies do the exact same thing with their bank loans to manage their exposure to changing interest rates and reduce financial anxiety. Now that we understand the basic idea, let us look at the formal financial contract. The most common type is the plain vanilla interest rate swap. In this setup, two counterparties agree to exchange a series of interest payments over a set period. One pays a fixed rate and the other pays a floating rate that moves with the broader market. These payments are calculated using a base amount called the notional principal. It is called notional because the companies never actually exchange this massive base amount, only the interest calculated from it. To understand the mechanics mathematically, we must calculate the exact cash flows exchanged by the two parties. We start with the fixed payment. The formula is CK equals N times RK times delta T. Here, CK is the fixed cash flow amount. N is the notional principal, which is the theoretical loan amount. RK is the fixed annual interest rate agreed upon, and delta T is the time fraction, such as 0.5 for 6 months. Because the fixed rate never changes, this exact dollar amount remains the same for every single period of the swap, providing complete predictability. Next, we must calculate what the other party owes in return. The formula for the floating payment is CF equals N times RF times delta T. The notional principal and time fraction are exactly the same as the fixed payment. However, we use RF, which represents the current floating interest rate observed in the market for that specific period. Because this floating rate changes every period based on the broader economy, this payment amount will be different every time they calculate it. If market rates rise, this payment increases, and if they fall, it decreases. In practice, the two companies do not actually send two separate checks to each other. Instead, they use a netting formula to find the difference. The formula is CN equals CF minus CK. Here, CN represents the net cash flow received by the party who pays the fixed rate. If the floating payment is larger, the result is positive, and the fixed payer receives a check for the difference. If the fixed payment is larger, the result is negative, and the fixed payer must write a check. This drastically reduces the money changing hands and lowers default risk. Let us visualize this exchange. On screen, you see a diagram with Company A and Company B. Company A sends a fixed rate payment to Company B, and in return, Company B sends a floating rate payment back to Company A. However, look at the bottom section, labeled netting process. Through netting, these two overlapping arrows are replaced by a single net cash flow arrow. Only the absolute difference between the floating and fixed rates is actually transferred, minimizing the risk of non-payment. Before we move on, let us see this with a concrete numerical example. Company Alpha agrees to pay a fixed rate of 5% and receive a floating rate. The notional principal is $10 million, and payments are every 6 months, making our time fraction 0.5. For the first period, the floating rate is 6%. First, we calculate the fixed payment Company Alpha owes. We multiply 10 million by 0.05 and by 0.5. This gives exactly $250,000. This outgoing obligation is locked in.
Continuing with our example, we now calculate the floating payment that company beta owes to company alpha. We use the exact same notional principal of $10 million and the same time fraction of 0.5. However, we substitute the current market floating rate of 6% or 0.06. Multiplying these three numbers together, we find that the floating payment is $300,000. Remember, this number is only valid for these specific 6 months, and the floating payer takes on the risk of it changing. Now we find the net difference to see who actually writes a check. We subtract the fixed payment company alpha owes from the floating payment they are supposed to receive. 300,000 minus 250,000 leaves us with a positive $50,000. This means company alpha does not send any money at all. Instead, company beta simply sends one check for $50,000 to company alpha. Because the floating rate was higher, the fixed rate payer came out ahead for this specific period. Now, let us see what happens in the very next 6-month period for the exact same swap. The economy has slowed down and the market floating rate has dropped to 4%. The fixed payment company alpha owes is still exactly $250,000 because the fixed rate never changes. We recalculate the floating payment using the new rate of 0.04. Multiplying the 10 million notional by 0.04 and 0.5 gives a new floating payment of $2 lakh. Let us calculate the new net cash flow to see the final result. We subtract the fixed payment of $250,000 from the new floating payment of $2 lakh. Notice that the incoming money is now smaller than the outgoing money, resulting in a negative $50,000. This negative sign simply means the direction of the final payment has reversed. Company alpha must now write a check to company beta for $50,000. The fixed rate payer loses money on this exchange because market rates dropped. These examples lead us to an important question. Why do companies use interest rate swaps in the real world? They are primarily used for risk management, specifically to fix a mismatch between a company's assets and liabilities. For example, a bank might issue long-term mortgages that pay a fixed rate, but fund them using short-term customer deposits that require paying a floating rate. If market rates rise rapidly, the bank suffers massive losses. By entering a swap where they pay fixed and receive floating, they perfectly cancel out this risk. To wrap up, let us review the key takeaways. An interest rate swap is a simple exchange of cash flows based on a theoretical principal amount. One party pays a predictable fixed rate while the other pays an unpredictable floating rate. Through the netting process, the actual money exchanged is just the net difference between these two obligations. This powerful tool allows businesses to transform the nature of their debt and protect themselves from dangerous fluctuations in the financial markets. You have now mastered the mechanics of interest rate swaps.